Now I'm going to explain you the third element or the third part of the electrolysis, and that is known as basically cell. So I am going to draw the diagram of the cell here. The cell basically consists of the electrolytic solution. It is present in the, you can say, beaker or anything, and the two electrode basically connected to this or dipped in this electrolytic solution, and this like these two electrode is basically connected with the battery, the negative terminal of the battery and the positive terminal of the battery. So the electrode which is connected to the positive terminal of the battery is basically known as anode, and in the same way with the negative terminal is basically known as cathode. And you need to mention that this is the battery, and the another thing, that it should be closed like this, and the electrode should be dipped in the solution, otherwise how could pass the electricity in the solution. And you have to mention that this solution is basically not the solution, it is known as specifically the electrolyte. So here we have an idea that we are going to break down the ionic compound in the molten or aqueous solution by means of electrolysis, and these three are basically the three portion of the electrolytic cell. The electrolytic cell contain the electrolyte. And what is electrolyte? Electrolyte is basically the solution which conduct electricity during the electrolysis, and the electrode is dipped in it. Electrode is what? It is a substance that pass electricity during electrolysis. There are two type of electrode, that is anode and cathode. Anode has positive charge, cathode has negative charge. And you should know that what is inert electrode. Inert electrode is basically the type of electrode which just pass the electricity but not take participation in the chemical reaction, and the two examples of it is platinum and graphite. The student should know that how to draw the electrolytic cell. Now the thing is, I'm going to explain you by giving the example that how I can get the sodium from the sodium chloride by using the technique of electrolysis. For example, I have the NaCl. When I'm going to melt it, so it will be in the molten state. As you know that in solid state the ions are not free to move. The ions are not free to move. But when you just melt it, basically what happened, the sodium and the positive ion and the negative ion become apart, and it will be converted into Na positive and Cl negative. And you should write that it is in the molten form. If the question is about write the state of it, so you are easily write the state that it is in the molten form. You can say write in the liquid and in the liquid. Okay. Now what will happen, as you know that this is the cell and it contain the electrode, the positive electrode and the negative electrode. So for example, this is the cell diagram, and it contains the Na positive ions and the Cl negative ion. So this is basically the anode, and this is basically the cathode. So what will happen, all the negative ion will move towards the anode and all the positive ion will move towards the cathode. As you know that the opposite charge attract each other. So now this happen inside the electrolytic cell. But what will happen next? Let me explain you by writing the half equation. Half equations. And this is really important. For example, when the sodium that have the positive charge move towards the cathode, what will happen? Sodium has deficiency of only one electron, and cathode is having the negative charge. It means cathode have lots of electron in it, efficient in the electron. So what will happen, sodium is moving towards the cathode because sodium wants to regain its original position or its original identity. So sodium will gain one electron at cathode and convert it into sodium. So when the sodium get one electron at cathode, sodium will start deposit on the surface of the cathode. In the same way, what will happen to the chlorine which is moving towards the anode? As you know that chlorine have -1 charge, it means chlorine has one more electron. So if chlorine wants to be in original state or original form, so chlorine have to lose that extra electron. So for losing the electron, you should write the minus sign. That minus sign shows you that you are basically chlorine is losing electron, and now chlorine is converting into chloride is converting into chlorine atom. But as you know that the chlorine is always in the diatomic form, so there should be two here, and for balancing it I just write two here and here. So in this way you can see that the chlorine gas is producing at anode and sodium metal in solid form depositing at cathode. So in this way I just separate the sodium and chlorine separately by using this technique which is known as electrolysis. So majority students face difficulty in writing the half equation. So for that purpose I'm writing and giving you the four example. For example, this is Na plus, this is Mg plus 2, this is Al plus 3, and this is H plus. Sodium has one less electron, so give it one electron. Magnesium has two electron left, so just give it 2 electron. Aluminium is deficient in of a 3 electron, so it is, you can say, just give it the 3 electron. And hydrogen has one less electron, so just give them 1 electron. So when sodium will get the 1 electron, it will be converted into sodium. Magnesium when gain 2 electron, it will become magnesium. Aluminium will become aluminium, and hydrogen become H. But keep it in the mind that the hydrogen is diatomic, so what will happen? You have to write 2 here, and for balancing it 2 here and 2 here. So I hope that you all understand that how to write the ionic equation for the positive ion, as I have given you the 4 example. Now let's move toward the negative ion. So for example, this is Cl negative, this is O minus 2, and this is N minus 3. So let me explain. Chlorine has one more electron, so it lose one electron. Oxygen has two more electron. Nitrogen has three more electron. So it is converted into Cl, it is converted into O, and it is converted to nitrogen. But the thing is that all these three gases are in the diatomic form naturally or in normal conditions, so I have to write 2 here. For balancing it, if one chloride atom losing one electron, so 2 chloride will lose 2 electron. So when one oxide ion is losing 2 electrons, so 2 oxide ion will lose 4 electron. In the same way, if one nitrogen is losing the 3 electrons, so the 2 nitrogen will lose 6 electron. So if a student is understanding that how to write these equation, he can get very good marks, because usually in paper these half equation comes to write the half equation at cathode, at anode. A student should learn that how to write it. I hope you understand. This is basically half of the portion of the electrolysis. In the next video I will gonna explain you that what will happen when the electrolyte not in the molten state, when the electrolyte is in the aqueous state, and when there will be the aqueous state, some more ions will be in it, and inshallah ta'ala I will going to explain you in the next video about it. Thank you.